and talk about section 1.7. 1.7 is dealing with quadratic equations. There are multiple ways for solving these types of problems. First of all, what is a quadratic equation? A quadratic equation simply means that you're going to have a term that has an x squared value somewhere in the problem. If you just had this piece, where the largest exponent on your variable is just x to the first, that would be a linear equation. So if you were to graph this, it would just form a straight line. You probably remember working with y equal mx plus b. That's what you would be working with there. By introducing the x squared term, we have a slightly more sophisticated graph. If we were to graph this type of problem, we would find that it would be a curve. It might be a parabola that opens up or a parabola that opens down. We don't get into graphing in this section. We're just working with basic ways to solve these types of problems. But quadratic just means you have a parabola. Okay? So methods for solving quadratic equations. Before we can talk about those, we need to discuss a certain property that we have concerning essentially real numbers. The first property that we need to talk about is called the zero product property. Sometimes it's called the zero factor property. I think this textbook might call it the zero factor property. It simply says that if you're multiplying any two numbers together and your answer comes out to be 0, what does that tell you about one of those numbers? The only way that you can multiply two numbers together to get 0 for an answer is that one of the original values has to be equal to 0. So that's what we're going to be using to help us solve these types of problems. So when I say zero factor property, that just simply means I've got two things multiplied together equal to 0, so I know that one of those original factors has to equal 0. So let's take a look at an example. Example 1, we're asked to solve each equation by factoring. We're going to look at part A. X squared minus x minus 12 equals 0. So it's very important that you're comfortable with factoring these types of problems. There are calculator tricks that will help you if you struggle with this. The first thing that I need to look at is I noticed that my coefficient on x squared is 1, so that makes it a little bit easier for me to handle. My last term is negative 12. Think about what numbers can be multiplied together to give you 12. The only choices that you have would be 1 times 12, 2 times 6, 3 times 4. Those are the only numbers that you're going to be working with. What pair of numbers can you add or subtract as needed to give you a negative 1 for your middle term? All right, hopefully you can see that you need to use 3 and 4. Because my first term is 1, I get to go ahead and put my numbers directly into the factored form for this. So my first term is going to be x and x there. How do I do my signs? How do I add or subtract 3 and 4 to give me a negative 1? Well, I know that they have to be multiplied to give me negative 12, so that tells me that they have to be opposite signs. To make negative 1, the larger number needs to be negative. So we need a negative 4 and a positive 3. So that is our factored form. People frequently ask me, is it okay if I wrote x plus 3 first and then x minus 4? Yes, that's fine. Order does not matter when you're working with multiplication. That's the commutative property of multiplication, tells us that the order does not matter. So x plus 3 times x minus 4 is fine too. All right, once we have it factored, notice you've got this chunk times, this is multiplication right here. You don't see anything between the parentheses, but we know that we're doing x minus 4 times x plus 3. That's equal to 0. So that's where the zero factor property comes in. I'm multiplying this piece times this piece equals 0, so one of those pieces has to equal 0. So my next step is to simply state that x minus 4 equals 0, or x plus 3 equals 0. And then solving these for x, I get x equals positive 4, x equals negative 3. And these could certainly be checked. You can certainly substitute these values back in for x, and they do check. Okay, so for part B, we're solving x plus 3 times x minus 4 equals 8. The first thing that we need to notice here is that this looks like it's factored for us, looks like they've done part of the work. But if you look carefully, you'll notice you've got a number over here that is not 0. If you do not have a 0 here, you've got to go back and do some work so that you can get 0 there. So what we need to do is we can certainly go ahead and subtract 8 on both sides. We also need to FOIL this out, combine like terms, and then factor it again. So let's go ahead and FOIL this. That'll give us x squared minus 4x plus 3x minus 12. And I'll subtract 8 on both sides. So you've got minus 8 equals 0. All right, and I'm going to let you go ahead and finish this on your own. See if you can figure it out. Pause the video and we will continue in a moment. Okay, so let's see how you did. If I combine like terms, I've got x squared minus x, and then negative 12 minus 8 gives me negative 20 equals 0. This can be factored. How did you factor that? You should have factored this as x minus 5 times x plus 4 equals 0. All right, now that you've got it factored and equal to 0, you're ready to use your zero factor property. So we're going to have x minus 5 equals 0, or x plus 4 equals 0. So x equals 5, or x equals negative 4. And again, these answers do check. The second method we have for solving quadratic equations is called the square root property. To understand how the square root property works, let's first think about an equation. Maybe we've got x squared equals 25, and we want to determine what the answer is. We want to solve for x. What numbers could I put in here for x that would give me a true statement? How many answers are there? Well, you probably can immediately recognize that 5 would be a solution to this because 5 squared equals 25. Is there another answer other than positive 5 that would work? So x equals positive 5. Is there anything else? Think about it for a moment. Pause if you need to before I give you the answer. If you think about it, you could also put in negative 5 because negative 5 times negative 5 also gives you positive 25. So you've got two answers. Okay? So notice you've got a perfect square here. X squared is a perfect square. You've got a perfect square equal some constant over here. Anytime that happens, there are going to be two values for x that are going to make this a true statement. Whatever the square root is on this side is going to work, and then the opposite or the negative version of that same number is also going to satisfy the equation. So the square root property tells us that we can solve a quadratic equation in this form by taking the square root of both sides, but also remembering to do plus or minus the square root of our constant. So that's what the square root property is telling us to do. Let's take a look at how this is going to work. So example 2 asks us to use the square root property to find all complex solutions to each equation. Okay? So if you look carefully at the square root property, it shows how let's read that together. For the square root property states for any real number k, the equation x squared equal k is equivalent to x equal plus or minus the square root of k. All right, so what they're saying here is that you need to start with the perfect square by itself on one side of your equation. So we need to isolate the perfect square. So for part A, we need x squared by itself on one side. So we need to first go ahead and add 9 to both sides. So now we have x squared equals 9. Now it looks like the starting point from the square root property rule. Once we have it in this form, do you know what to do? You probably do. Go ahead and take the square root of both sides. So you'll have x equals, but remember you're going to do plus or minus the square root of your constant. So x equals plus or minus 3. And that is our answer. In the homework, they may ask you to express your answer as a solution set. So they will have these curly braces, which is a little bit tricky to learn to draw. Okay, so those are my curly braces. That's my set notation, and I would just list my answers inside. So -3, comma, +3. For part B, we want to solve 2x squared equal 1. All right, does this currently have the perfect square isolated for us? No, it does not, because 2 is not a perfect square. What can we do with the 2? We need to get it out of our way, so we need to divide both sides by 2. So that will give us x squared equals 1/2. Yes, you have a fraction, but it's okay. It's not going to be that bad. Go ahead and take the square root of both sides. So you'll have x equals plus or minus the square root of 1/2. The square root can be broken apart. So we have x equals plus or minus the square root of 1 over the square root of 2. So x equals plus or minus. We know that the square root of 1 is 1. The square root of 2 is just the square root of 2. That's as precise as we can get with that one because that's an irrational number. So we've got plus or minus 1 over the square root of 2. All right. Now, this is correct, but it's not in the form that you're going to be asked to give it in. Do you know why this is not in the form that you're going to need? It goes back to rationalizing the denominator. We've got a radical in the denominator of our fraction. That is something that we do not want to have. So if you think way back to section, I think it's B2 or B3, I think it's in B2. We can get rid of that square root in the denominator. We need to rationalize our denominator, so we want to multiply the top and the bottom of our fraction by the square root of 2. That will give us x equals plus or minus 1 times the square root of 2 over the square root of 2 times the square root of 2, which is going to give you 2. So we've got plus or minus the square root of 2 over 2 for our answer. If we write this in set notation, we're going to have, excuse me while I adjust my boards. So if we list these two answers in set notation, it's going to be curly braces, negative square root 2 over 2, comma, positive square root 2 over 2. We generally like to list them from smallest to largest. However, order is not required here, so if you put the positive answer first and the negative one second, that's okay too. So this is the way our answer would look in set notation. All right, example 2, part C, we've got 2x minus 1 quantity squared equal to 0. We're still asked to use the square root property to solve this. This one is set up very nicely for us to use the square root property because it does have the perfect square over here already for us. That 2x minus 1 quantity squared is a perfect square, meaning if you take the square root of it, you just get the 2x minus 1 out. You're probably noticing that anytime you have a square and a square root together, they always cancel each other out. So that's going to continue to be true. So let's go ahead and take the square root of both sides. We'll have 2x minus 1 equals, now my rule tells me to do plus or minus the square root of the constant. So that's what I'm doing. So 2x minus 1 equals plus or minus the square root of 0. What is the square root of 0? Take a moment and think about that before I tell you. I have people frequently tell me that the square root of 0 is undefined or not possible, but I think they're forgetting what square root means. Square root means you're looking for a number that you can multiply by itself to give you whatever's inside. Well, because 0 times 0 equals 0, the square root of 0 is 0. So we've got plus or minus 0. Do I really need my plus or minus this time? No, because there is no negative 0. So we've got 2x minus 1 equals 0, and we'll go ahead and solve this for x. So let's add 1 to both sides. divide by 2. We get x equal 1/2. Again, if we are asked to write this in set notation, we'll just simply list 1/2. That's the only number that goes in there.